Hello, my dear students. Welcome to my YouTube channel, Dr. Mohan with Digilan. Today, let us study the chemical properties of an acid and bases. Okay, so what is that? Let us study in detail. Okay, whenever you see the reaction with metals, okay, the acids when they react with metal, okay, it gives salt and hydrogen gas. So this is a very common reaction which takes place in presence of an acid. Okay, when an acid reacts with a metal, it gives rise to salt and hydrogen gas. So if I take an example, hydrochloric acid, when it reacts with an zinc, it gives the zinc chloride and hydrogen gas is evolved. Okay, if you react the base with the metal, it gives the salt and hydrogen gas. Okay, similarly, we will take the example to understand how the metals they react with bases. Okay, that example is sodium hydroxide. When it reacts with the zinc metal, it gives the zinc zincate. Okay, sodium zincate is going to form, so that along with that hydrogen gas is also going to evolve. So in this particular type of reaction, so if you test for hydrogen gas it will be released by tested by bringing a burning candle near the gas bubbles. It burns with the pop sound. So whenever the hydrogen gas is released, okay, this can be tested, okay, by bringing the burning candle near the gas bubbles, then it will burst with the pop sound because of the presence of hydrogen gas. This confirms the presence of hydrogen gas. If you go for the reaction of zinc granules with the dilute sulfuric acid and testing hydrogen gas by burning, so okay, so this is the setup we have done, okay, so that the hydrogen gas it will be evolved as I told you. So this hydrogen gas which has been evolved by the reaction, it will enter to the another container where the soap solution is present, where the soap solution, because of the presence of hydrogen gas which comes through the delivery tube to the soap solution, it shows you the bubbles which indicates that the evolution of the hydrogen gas. And moreover, as I told you, the burning candle, when it is brought near the hydrogen gas, the already formed these bubbles, they will burst because of the presence of hydrogen gas. This confirms the evolution of hydrogen gas in this case. So if you go to second type of the reaction, okay, that is reaction with metal carbonates and hydrogen carbonates. Okay, so all metal carbonates and hydrogen carbonates react with the acids to give a corresponding salt, carbon dioxide and water. So this is another important the chemical property, okay, which will be studied in this fashion. So if you take in one example, okay, that is sodium carbonate, when it reacts with the HCl, it gives rise to sodium chloride. Along with that, water is formed and carbon dioxide is evolved. Okay, so this is the another type of reaction which we can study. Okay, after that we can test the carbon dioxide also. Okay, what is that? Carbon dioxide can be tested by passing it through the lime water. Okay, when you are going to pass the carbon dioxide through the lime water turns milky. So this is a characteristic reaction which will be observed. So that calcium hydroxide reacts with carbon dioxide to give rise to calcium carbonate. Okay, so that is soluble salt, along with that water is formed. So when excess carbon dioxide is passed, milkiness disappears. Okay, so the calcium carbonate plus carbon dioxide plus water give rise to calcium bicarbonate. Okay, so which is insoluble salt, so which is going to form in this case. So bases do not react with the metal carbonates and hydrogen carbonates. Chemical properties of acids and bases when we study. So in this, the reaction of acids and bases with each other, what happens, let us understand. Okay, this is a very peculiar reaction and very what we can say very famous reaction. Why? Because this is also called as neutralization reaction. Okay, when an acid reacts with a base, the hydrogen ion of an acid combines with an hydroxide ion of an base. That is, hydroxyl ion is OH minus ions, it will be there. So acid consists of H plus ions. Okay, so when they react with the base, okay, they forms water. So as these ions combine together, they form a water instead of remaining free. Okay, thus both neutralize with each other. So they get neutralized because, as I told you, this is a neutralization reaction in which acid reacts with a base which give rise to salt and water. Okay, so in this reaction between an acid and the base, both neutralize each other. It is also known as neutralization reaction. Already I have mentioned this. So the example is sodium hydroxide, which is a strong base, when reacts with the hydrochloric acid, which is a strong acid, okay, to form sodium chloride and water. So this is the reaction what we are going to write. NaOH when reacts with the HCl, which give rise to Na plus Cl forming NaCl, remaining OH and H forms the water. So the next reaction, okay, that is reaction of acids with the metal oxides. If you want to study, metal oxides react with acids to give salt and water. So the metal oxides along with an acid, okay, when it reacts, it gives rise to salt and water. So if you want to give the particular example for this, we have a very good example here. So the copper oxide, when it reacts with the dilute hydrochloric acid, dilute HCl, it forms copper chloride. Okay, it's also called as cupric chloride also, which is a salt and water. See there, CO, okay, which is called as copper oxide. When it reacts with the HCl, it forms the copper diode, that is cupric chloride is formed, along with that water is also going to form. So this copper oxide is black in color. So the color of the copper oxide is black. So when dilute hydrochloric acid added, the color of the solution, it becomes a blue green due to the formation of copper chloride. So copper chloride, it will be formed. So which is a blue green in color, which is going to form in this case. So this is the actual reaction which takes place in this type of reactions. Okay, so now with the, if you want to study the strength of an acid or a base, okay, so the strength of an acid or a base, it depends upon how many the number of H plus ions are released, or how many number of OH minus ions are released in the case of bases, produced them respectively. Okay, so depending on the number of H plus ions released, you can decide them as a strong acid or a weak acid. Similarly, the number of OH minus ions produced, you can decide is it a strong base or a weak base. So based on this ability to dissociate into ions in the solution, acids and bases are classified as strong acid or base, weak acid or a base, as I told you already. So the number of H plus ions, how many number of, if it is completely dissociated the H plus ions, you can say that it is a strong acid. If it is completely dissociating the OH minus ions, you can say that it is a strong base, and vice versa. So in the case of strong acids, the acids which completely dissociates in water to produce a large amount of H plus ions are called as strong acids. So the, for example, as I told you, HCl, okay, sulfuric acid and nitric acids are strong acids because the H plus ions which are released on hydrolysis are maximum. So they get the completely ionized in the form, so, okay, in the water to form the ions. So that is HCl, okay, when undergoes the hydrolysis process, H plus ions are released and Cl minus ions are also released in an aqueous solution. Similarly, if we take a weak acids, okay, the acids which get partially ionized in water to produce a small amount of the hydrogen ions are known as weak acids. So for example, so acetic acid partially dissociates in water to produce the small amount of hydrogen ions. So very good example to understand this type of reactions, because also I told you that acetic acid is a weak acid, okay, which releases the H plus ions on hydrolysis, but not completely. It is a partially ionized, okay, and the acetate ions are also formed CH3COO in aqueous media. Okay, so this is how they are going to be considered. So then if you go for a strong bases, okay, so bases which are completely ionized in water, okay, to produce a large amount of hydroxide ions are called as strong bases. Similarly, that is the example is NaOH, sodium hydroxide, potassium hydroxide, etc. Whereas in the weak bases, if you consider the strong base, just opposite to this are weak bases, okay, they partially dissociates in water to give the lesser number of H plus, that is OH minus ions, okay, they are weak bases. Example is ammonium hydroxide and calcium hydroxide, they are the examples for weak bases.